Welcome to today's Explainer. We are about to embark on a really exciting journey. Basically, we're going to learn how to read the most complex, most fascinating map in existence, the human body. If you've ever wanted to truly understand the actual blueprint of how we're put together, you are in exactly the right place.
But, before we look at the single bone, muscle, or organ, I actually want you to think about this question right here on the screen. What does the word anatomy actually mean? We throw the term around all the time, right? But the origin of the word holds the absolute key to how we study it.
Well, it turns out the word anatomy comes straight from ancient Greek. It's a combination of ana, which means up or apart, and tomi, meaning a cutting. So quite literally, anatomy means cutting up or apart. Learning anatomy isn't just about rotely memorizing parts. It's essentially learning a brand new, highly descriptive language. It's a language based entirely on physical structure and function, and it allows healthcare pros, scientists, and students to communicate with just incredible precision. So here's our game plan for this explainer. First, the language of anatomy. Second, levels of organization. Third, navigating the human map. Fourth, the 11 organ systems. And finally, number 5, a hands-on look at the wrist.
All right, let's kick things off with section 1, the language of anatomy.
Okay, let's dive into this. Back in the day, it was incredibly common to name anatomical structures after the person who discovered them. We call those eponyms. For example, the Eustachian tube was named after an Italian anatomist named Eustachia. But think about it. That name tells you absolutely nothing about what the tube actually does or where it lives in the body. Today, the medical field vastly prefers descriptive terms. So the Eustachian tube is now much more commonly called the auditory tube. Right away, just hearing the word auditory clues you in that this structure has a role in sound or at least lives near the ear. See, anatomical language is designed to help you figure out function and location, not just memorize a bunch of history.
Moving right along to section 2, levels of organization.
And this brilliantly illustrates the whole hierarchy of how we are built. We examine the body by starting at the absolute most fundamental building blocks and ascending all the way to the most complex structures. Notice how we start way down at the chemical level with atoms and molecules. Those combine to form organelles, which are kind of like tiny organs inside our cells. Then, cells group together to form tissues, think muscle or nervous tissue. Tissues build the big stuff, the organs, like your liver or stomach. Organs team up to create entire organ systems. And finally, all those systems form the complete organism, you. Nursing and medical students rely heavily on understanding this exact structural hierarchy, because honestly, you can't understand the whole organism without first understanding that microscopic foundation.
Which brings us to section 3, navigating the human map.
If you're looking at a geographical map, you obviously need to know which way is north, right? Well, in anatomy, our true north is the anatomical position. This means standing upright, feet together, arms at your sides, with the palms facing forward. You'll also hear this called the supine position. Now, why does this matter? Imagine a doctor asking if a patient's stomach is inferior to their diaphragm. The answer has to be exactly the same whether that patient is standing up, lying down in a bed, or literally doing a handstand. By having this one standard frame of reference, healthcare professionals make sure they never get lost when describing the body.
So once we have our true north, we can start slicing up the map. On the left here, you'll see the anatomical planes that divide the body. The sagittal plane divides it into left and right. The frontal or coronal plane divides it into front and back, and the transverse plane divides it into top and bottom halves. Then over on the right, we simplify the abdomen into 4 quadrants, right and left, upper and lower. These act just like GPS coordinates on a map to help a clinician pinpoint exactly where a specific organ, like the gallbladder or the appendix, lives.
Let's actually translate some everyday layperson terminology into our new anatomical language. Take a second and actually look at your own arm as we rapid fire through these. Ready? What you call your armpit is actually your axilla. Your upper arm? That's the brachial region. That front part of your elbow where they draw blood at the doctor's office? That is the antecubital area. Your wrist is the carpal region, and your thumb is your pollex. See? It is the exact same body you've always had. You're just finally learning its true names. All right, section 4, the 11 organ systems. Memorizing 11 different systems all at once might sound a little daunting, but students use a fantastic mnemonic to make it an absolute breeze. It's Run, Mrs. Lydic. This stands for reproductive, urinary, nervous, muscular, respiratory, skeletal, lymphatic, integumentary, which, by the way, is just your skin, hair, and nails, digestive, endocrine, and cardiovascular. Boom, all 11. Now, while we study these 11 systems individually to make things easier, the absolute most important concept in physiology is that they all interrelate. They work together in constant, dynamic harmony to maintain a stable internal environment no matter what crazy stuff is happening on the outside. And that delicate, incredibly crucial, life-sustaining balance, that is known as homeostasis. And finally, Section 5, hands-on with the wrist. I want you to hold up your hand and just look at your wrist for a second. Have you ever wondered why it's so structurally complex? It's because of the sheer range of motion we need for our daily activities. So the crucial point is that your wrist actually has 6 degrees of freedom. You've got flexion, which is decreasing the angle by bringing your palm towards you. Extension, bending it back. Abduction, moving the hand away from the midline of your body. Adduction, bringing it back towards the midline. Pronation, rotating your palm to face down. And supination, rotating your palm to face up. That immense multi-directional mobility requires some seriously specific biological engineering. Let's trace the bones down to the fingertips. We start right in the hand with the metacarpals, which form the base of your palm and end right at your knuckles. Then we hit the phalanges, which are your actual finger bones. Each of your 4 main fingers has a proximal, intermediate, and distal phalanx. But notice your thumb, the pollex. It only has 2 phalanges. It's entirely missing that middle bone. However, on the ventral surface of the thumb, there are 2 tiny little sesamoid bones. These little guys are so cool. They act almost like pulleys, protecting the tendons and allowing us to flex and adduct our thumb with a lot of power. Now, to connect those hand bones to the forearm, we have the carpal bones of the wrist. There are 8 of them, tightly packed into 2 rows. It's a bit of a jigsaw puzzle. To memorize this complex little cluster, medical students use a rather crude but honestly incredibly effective mnemonic. Some lovers try positions that they can't handle. Now, what's really interesting about this slide is how we decode that mnemonic. We move from lateral to medial, starting with the proximal row. Sum is for the scaphoid. This bone actually forms the floor of what's called the anatomical snuff box, right at the base of your thumb, and it takes the absolute brunt of the impact if you happen to fall on an outstretched hand. Lovers is the lunate, which is the most commonly dislocated wrist bone. Tri is triquetrum. Positions is the pisiform, which is another one of those tiny sesamoid bones. Then moving to the distal row, that is trapezium. They is trapezoid. Cant is capitate, the largest carpal bone. And handle is the hamate. The hamate actually has this tiny little hook on it called the hamulus. Interestingly enough, golfers sometimes fracture this exact hook if they swing too hard and hit the ground on their downstroke. No way, right? Let's wrap up with one final thought. We've gone from the ancient Greek roots of a word all the way to tracing the exact structural mechanics of the tiny bones inside your wrist. Anatomy isn't just dry diagrams in a heavy textbook. It is the living, breathing, moving reality of your very own existence. So I'll leave you with this. Next time you look at your own hand, flex your wrist, or just move your pollex, how will you read the map differently? Thank you so much for joining me for this explainer today. Keep asking questions and keep exploring.